3 million years ago, the oceans were patrolled by an animal of almost incomprehensible scale. At up to 18 meters long, the Megalodon was a massive creature that dominated the warm coastal waters of the prehistoric world. Looking at its physical structure, you can see an anatomy built for high-speed ambush. Its dense musculature and powerful crescent-shaped tail provided the explosive propulsion needed to chase down heavy prey. But sheer speed requires guidance. To find prey in the vast ocean, the Megalodon utilized electroreception, a specialized sensory biology that allowed it to detect the faint electrical fields and pressure waves generated by distant moving animals. Once it closed the distance, it deployed rows of heavy, serrated teeth. These were designed to crush thick bone and shear massive pieces of flesh in a single bite. Every trait points to a highly tuned biological machine. Evolution engineered the Megalodon to perfectly exploit a warm, target-rich environment. The ancient oceans were highly abundant. The Megalodon shared these waters with other giant predators, like the massive prehistoric sperm whale Leviathan. They kept a respectful distance from one another, supported by an ecosystem overflowing with food. Its hunting strategy was devastating. Stalking beneath a prehistoric whale, the shark used the dark water as camouflage to launch into its blind spot. For over 10 million years, this method worked flawlessly. The adult Megalodon faced no natural predators and sat entirely unchallenged at the top of the global food chain. Despite this 10 million year reign, the undisputed king of the ocean vanished. If an animal is perfectly adapted and faces no natural predators, its total disappearance from the fossil record suggests a catastrophic mismatch between its biology and the world around it. The explanation for that collapse lies in the hidden tax of being gigantic. Pushing an 18-meter frame through the water requires an extreme amount of daily energy. This chart compares the daily caloric intake required by an 18-meter Megalodon to smaller marine predators. Its massive bulk demanded constant fuel, met by blubber-rich whales. If populations dropped, it crossed a critical caloric deficit threshold and starved. It also faced a second geographical constraint. The species relied on warm, shallow coastal lagoons to serve as nurseries. These specific zones kept their vulnerable young safe from open ocean predators. The Megalodon's immense size was an expensive biological liability. Its survival was chained to a steady supply of whales and highly specific, stable coastal temperatures. Around 3 million years ago, the Earth's climate shifted. The planet entered a period of global cooling. Ice caps expanded and ocean temperatures dropped. The prehistoric whales adapted quickly. Utilizing their warm-blooded biology, they migrated away from the equator into the newly formed freezing waters near the poles. The Megalodon could not follow them. Bound by its biology to warmer waters, the shark was suddenly isolated from its primary food source. Simultaneously, as global water froze into glaciers, sea levels plummeted. The shallow, warm water lagoons drained away, leaving the Megalodon nurseries exposed or completely destroyed. In the remaining coastal waters, the ancestors of the modern great white shark thrived. Because they were smaller, they required far fewer calories and could survive by scavenging smaller fish, easily outcompeting the starving giants. The environment abruptly changed the rules of survival. The immense size and hyper-specialization that once kept the Megalodon on top became the very anchors that sank it. The massive sharks died out, and over millions of years their heavy, enamel-coated teeth sank into the quiet ocean floor, slowly buried under thick layers of sediment. Today, scientists work in laboratories to reconstruct the timeline of this collapse, analyzing these scattered fragments to measure ancient ocean temperatures and track the species' decline. The exact locations where paleontologists find these teeth inland perfectly map to the vanished shorelines of the Pliocene epoch. These physical fossils act as permanent geological records. They prove that no species is immune to a large-scale environmental shift. The Megalodon story is just one chapter in a much larger history of specialized biology meeting an immovable environmental wall. The dodo thrived on a predator-free island until humans introduced competing species, turning its lack of flight from an advantage into a fatal flaw. The prehistoric Smilodon developed massive canine teeth to hunt huge Ice Age herbivores. a specialization that left it unable to adjust when those prey animals disappeared in a warming climate. The fates of these giants demonstrate that extinction is rarely about a lack of strength, it is about a lack of flexibility. When an environment shifts, whether through geological cooling or modern human activity, specialization becomes a trap. Size and dominance offer no protection when the foundation of an ecosystem breaks. These fossils serve as a reminder that the wildlife we see today exists within a fragile balance, and once a species' specific requirements are gone, the animal itself soon follows.